All right, so here's the last part of Note 6.3, Day 2. We're going to do homework problem number 39. So this is the Famine Relief Airdrop. A relief agency drops food containers from an airplane on a war-torn famine area. The drop was made from an altitude of 1,000 feet above ground level. So again, notice I'm in parametric mode, and I am just going to go ahead and show you the simulation. So here comes the drop. So notice that our motion is going, it's vertical, and it's starting at the top and it's coming down. Okay, just like if something was dropped from the sky. And remember, we are going to use parametric equations to describe this vertical motion from up to down, and it's going to be with x and y both in terms of time t. Oops, sorry, I kind of spoiled the whole fun there. Okay, so t is time in seconds. Okay, and let's take a look at the algebra here. So first of all, again, we're thinking about projectile motion. Notice this time, though, the initial velocity was 0 because we just dropped it from the plane. We did not give it an initial velocity. So when we make parametric equations, 2 is quite arbitrary for the x. I decided to put x equals 2. You could have put x anywhere you want. I used the line 2. Okay, so here are my equations. And again, you have to decide on what to use. They wanted you to look at the first 6 seconds. When I did that, though, it was not the entire simulation. So let's just take a look at what I did. So here are my equations. There you go. And again, there's my window. I decided to go 10 seconds just to see it go all the way to the ground. Notice that my x was arbitrary at 2, so I went from 0 to 4, so you can see that vertical line. My t-step was 0.01, so I made a calculation every 0.01 second. Notice that I went to 1001 just so you could see when it was dropped from the plane. So if I decide to go to 6 seconds, let's see what happens. All right, so we'll go to y equals, we'll have it do the whole thing again. So here goes. So my relief is dropped from the plane. And this is, t is going from 0 to 6 seconds this time. And you're going to see it did not get all the way to the ground. And that's when the parachute must have come open at about 4 seconds. So here we go. And there we go, it stopped at 6 seconds. So for this last question, if we have our equation and they want to know what's going on when the parachute's open, if you put 4 in for t, you get 744 feet. So the parachutes must have opened when the food containers were 744 feet from the ground.